Welcome back. In this lesson, we're going to extend what we learned in the last lesson. We learned how to solve inequalities by adding and subtracting. Now we're going to work on multiplying and dividing. So we're going to go ahead and look at what the rules are to solve inequalities by using multiplication and division. So here are your rules. We can multiply both sides of an inequality by any number, and it doesn't change the sign of the inequality. And likewise, we can also divide by any number as long as this is a positive number. Okay? There's a different rule when we multiply and divide by a negative number, and we'll talk about that soon. Here's an example. If I want to solve this inequality, 7y greater than negative 42, just like an equation, we would divide both sides by 7. We would get y greater than negative 6. On the right-hand side, x is multiplied by 1/3. So to get rid of that 1/3, we would multiply by the reciprocal, which is 3. So when I multiply by 3 on both sides, I get x is less than or equal to 24. Here are 3 for you to work on. Go ahead and actually solve each of these and bring those to class. I'm not going to take time in the video to show you that, but I will check those as part of your lesson check. What happens when each side of an inequality is multiplied or divided by a negative number? Well, here is a new rule for you. And this kind of shows why the rule happens. So if we were to graph 3 and 5 on a number line, we have those right here, okay? If we multiply each of those numbers by -1, we get -3 and -5, right? So if we want to maintain our inequality, it says since 3 is to the left of 5, 3 is less than 5. But over on the other side, once we multiplied by -1, -3 is greater than -5. So the inequality flips, okay? It goes the other way. And so that's exactly what's going to happen when we multiply or divide by a negative number. It's going to flip the inequality the other way. So when you multiply or divide each side of an inequality by a negative number, the direction of the inequality symbol must be reversed for the inequality to remain true. Here's some examples for you to look at. 8 is greater than 5, but when we multiply by a negative number, notice the next step, once we multiply by that, this flips the other way. Okay? 8, we started out with 8 greater than 5, but when we multiplied, it flipped to being less than. Same thing on the right-hand side. Okay? Common error, there's a little warning here, do not reverse the inequality symbol just because there's a negative sign in the inequality. For example, if you have 7y is less than -42, if you're dividing by a +7, that doesn't flip the inequality. The only time you switch the inequality is when you multiply or divide by the negative number. So be careful of that. So here are some examples. A divided by -2 greater than or equal to 8. We want to get a by itself, so we're going to multiply by -2. So since we're multiplying by a negative number, we will flip the inequality on this one. And we get a is less than or equal to -16. On the right-hand side, we're going to divide by -6. That will flip our inequality the other way. And we have n is greater than 4. All right, I'm going to work through D with you. We have C divided by -7 less than -14. So in order to get C by itself, we need to go ahead and multiply by -7. So I'm going to do that here. -7 times C over -7 is less than -14 multiplied by -7. Okay? So the -7's will cancel on the left-hand side. And I'll have C, now I need to flip that inequality, is greater than, negative times a negative is a positive, and that looks like that's going to be about 98. E and F, I want you to go ahead and work on those and bring those answers to class, and I'll check those as part of your lesson check. Here's a word problem example. Manny was trying to break his school's record by getting 61 hits in one season. Halfway through the season, he already had 34 hits. He averages 2 hits per game. Write and solve an inequality to find how many more games it will take at that rate for him to have at least 61 hits. So here's our equation. He already has 34 hits. He gets 2 per game, and we want that to be greater than or equal to 61. To solve this, we need to subtract 34 from both sides, and then we're going to divide by 2. When we do that, we find that G is greater than or equal to 13.5. So as long as he if he plays only entire games, he should have 61 hits after he's going to need a total of 14 games. We need to round this up because he's not going to play part of a game. And this is your last problem. Joan has a total of $250. If DVDs cost $18.95 each, write and solve an inequality to find how many DVDs she can buy and still have at least $50 left. So bring your answer to that one to class, and we will see you next time.